Good day, everyone. Let's talk about geometric sequence, or also known as geometric progression. So first, let's define the geometric sequence. Geometric sequence is ordered set of numbers that progresses by multiplying or dividing each term by a common ratio. Note that if we multiply or divide by the same number each term to make the sequence, it is called geometric sequence. The common ratio is the same for any two consecutive terms in the same sequence. So that is geometric sequence. So geometric sequence formula is a sub n is equal to a sub 1 times r raised to n minus 1, where a sub n is the nth term or the general term, and a sub 1 is the first term, and n is the term position, or ito yung madalas nating hinahanap sa given sequence, and r is the common ratio, or ito yung tina-times or dinidivide natin sa first term para makuha yung second term. So, I have here an example of sequence which is 4, 12, and 36. Since our common ratio is not given and our a sub 1 is given, so first let's find the common ratio, which is we need to divide 12, the second term, and the first term divided by 4. So 12 divided by 4 is equal to 3. So our common ratio is equal to 3. So let's proceed to find the fourth term, which because the a sub 1 and ratio is given. So our formula is a sub n is equal to a sub 1 times r raised to n minus 1. So our a sub 4 a sub n is equal to 4 because the fourth term is missing. So a sub 4 is equal to 4, which is the first term, times ratio, which is 3, and raised to 4 minus 1. So a sub 4 is equal to 4 times 3 raised to 4 minus 1 is equal to 3. So a sub 4 is equal to 4 times 3, 3 times raised to 3 is equal to 27. So a sub 4 is equal to 3 times 3 is equal to 27, right? So a sub 4 is equal to 4 times 27 is equal to 108. So our fourth term in this sequence is 4, 12, 36, and the fourth term is 108. I have here another example of geometric sequence, which is 12, 24, 48, and 96. So in this sequence, we need to find the fifth term of this given sequence. So our a sub 1 is given, but our common ratio is not. So we need to find the common ratio, which is we need to divide the a sub 1 and a sub 2. So a sub 12 divided by 24 is equal to 2, since our common ratio is now given. Then let's proceed to find the fifth term of this given sequence. So let's have the formula, which is a sub n is equal to a sub 1 times r raised to n minus 1. So a sub 5 is equal to 12 times 2, it is the common ratio, raised to 5 minus 1. So first, let's minus the exponent, because that is the rule of PEMDAS. A sub 5 is equal to 12 times 2, and 5 minus 1 is equal to 4. Correct. And a sub 5 is equal to 12 times 2 raised to 4. So we need to times these 2 itself by times kung ilan yung nasa taas. So 2 times 2 times 2 times 2 is equal to 16. So, next is a sub 5 is equal to 12 times 16 is equal to 192. So, our fifth term in the sequence is 192. So, I have here another example of sequence, which is 5, 10, 20, 40, and 80. So let's find the sixth term of this sequence. So first, since the a sub 1 is given, which is 5, and a sub 2 is given, which is 10, so we need to divide this 2 to find the common ratio. First, 10 divided by 5 is equal to 2. So, our common ratio is equal to 2. Since the common ratio and a sub 1 is given, let's proceed to so let's proceed to find the sixth term since a sub 1 is given and ratio is given. So first, let's have the formula, which is a sub n is equal to a sub 1 times r raised to n minus 1. Since sixth term is missing, let's write a sub 6 is equal to a sub 1, which is 5, and r, which is 2, raised to 6 minus 1. So first, let's minus the exponent, which is 6 minus 1. So a sub 6 is equal to 5 times 2. 6 minus 1 is equal to 5. Next, a sub 6 is equal to 5 times 2. 2 times 5, or let's times it 5 times the 2. So, the answer is 32. So, a sub 6 is equal to 5 times 32 is equal to 160. So, our sixth term in this sequence is 160. So, let's have the differences of arithmetic and geometric sequence, which is arithmetic and geometric sequence are types of sequence, but they have distinct characteristics. So first, in the method of progression. Sa arithmetic sequence kasi, each term is obtained by adding a constant differences to the preceding terms. Nagcreate ito ng linear progression where the sequence develop in uniform manner. Sa sa geometric sequence is it is a sequence of each term is obtained by multiplying. So, since sa arithmetic is adding, sa geometric sequence naman is multiplying. It is obtained by multiplying the preceding term by a constant ratio. This result in an exponential growth or decay of pattern. So number 2 is in the nature of progression. Arithmetic sequence exhibit a constant difference between consecutive terms. This means that difference between any two consecutive terms in the sequence remain the same throughout, or pare-pareho lang siya hanggang dulo. And in geometric sequence naman, showcase a constant ratio between consecutive terms. This implies the ratio of any term to its preceding term is consistent across the entire sequence. So third is in application. Arithmetic sequence are commonly used to model linear situations such as financial planning, where regular contributions or withdrawal occur over time. Sa geometric sequence naman is find applications in scenarios involving exponential growth or decay, such as popular growth, um, compound interest, calculation, or radioactive decay. So last, they have differences in terms of formula, which is arithmetic sequence. A sub n is equal to a sub 1 plus n minus 1 times d. Kung saan yung a sub n, it is the nth term, and a sub 1 is the first term, and d is the common difference. So sa geometric sequence naman is a sub n is equal to a sub 1 times r raised to n minus 1. Kung saan yung a sub n it is the nth term, and a sub 1 it is also the first term, and the r it is the common ratio. So remember that both geometric sequence and arithmetic sequence offer insight into organizing numbers, provide methods for determining successive terms with the sequence, and each term in both sequence relies on the relationships with preceding terms to establish the sequence pattern. I hope that you've learned a lot, and thank you for investing your time to watch this video. Have a good day, everyone. Bye-bye.